Hi, my name is Amy. I'm a data scientist at Zindi. This competition is sponsored by Lacuna, and the data set is from a Lacuna dataset grantee, David Adelani, from the Masakhane project. I was introduced to NLP through Zindi and introduced to parts of speech by David, I think 3 weeks ago. So when I've had the privilege of working with NLP, I've never had to think down to the parts of speech level. And he's opened up my eyes, and I hope others learn from him and take this forward. On the call with me, I have Jennifer Pratt Miles, who's a partner at Meridian Institute and heads the Lacuna initiative, the Lacuna Fund, and she can explain a bit more. And we've also got David Adelani, who's currently a DeepMind academic fellow, but he's had an amazing academic journey, and he's definitely someone to reach out to if you want to hear more about his academic background. I'm going to share my screen, and I'm going to show you where to find the competition if this is your first time on Zindi. Give me a second. I think you can see my Zindi screen, is that correct?
Yes.
Brilliant, thought you could see my slide. So this is Zindi. The second competition is the Lacuna competition for $7,000. The data set is from Masekhane, which David is a part of, and he'll explain a bit more about Masekhane. The dataset creation was funded by Lacuna as well as this competition. The evaluation metric is accuracy. We have $7,000 in prize money, including 7,000 Zindi points. Anyone who makes a submission onto the leaderboard gets Zindi points, and that adds to your Zindi profile. This competition ends on the 17th of September. If you're new to Zindi and would like to know how to make your first submission to a competition, or how to create a team, how to update your profile, how to use Colab if you don't have Python on your computer, we recommend using Colab, and some rules to take note of. We encourage you to participate in a team. You don't have to. Please don't share any code privately with friends. If you're going to share code, rather share it on the discussion board or join with a teammate, and then you can share within your team. If you would like to use this data set outside this competition, you are allowed to use it with the CC by 4.0 NC license, and please remember to cite it using the citation. And you can make 10 submissions per day. So this is 10 predictions per day and a total of 300 for the competition. I'm sure you won't run out of submissions. On the data page, you'll be able to find the 19 languages for the test, for the train set, by going to the repo. Give David a star, and you can download the data. And here is the starter notebook, which David will be going through. You will be able to find the test set, which is the Luo and Setswana data. David, what is the right word? Just letters together, strings together that don't make sense if they're not in a sentence, and a sample submission of what it needs to look like. I'm going to hand over to Jennifer now to tell us about Lacuna. Over to you, Jennifer.
Thanks, Amy. I'm going to pull up a few slides. And as Amy said, I'm Jennifer Pratt Miles. I'm let's see. There we go. I'm a partner with Meridian Institute, which is a not-for-profit organization, and Meridian serves As the Secretariat for Lacuna Fund at Meridian, we help people solve complex challenges and make informed decisions and implement solutions all through collaboration. Lacuna Fund was formed to address gaps in data sets that are used to train and evaluate machine learning models. And these gaps are noticed in that often entire data sets are missing for entire populations or geographies. And where data are available, they're often missing key information. And these gaps can lead to bias and inaccuracies. So Lacuna Fund is the world's first collaborative effort to provide data scientists, researchers, and social entrepreneurs in low and middle income contexts globally with the resources they need to fill these gaps and produce machine learning data sets that will address urgent problems in their communities. Lacuna Fund is made possible by these funding partners. These include both private philanthropies and public sector funders, and we're really grateful for their support. In terms of filling the data gap, to date, Lacuna Fund has been able to support 58 data sets around the globe. 42 of those are based in Africa, and 17 of those have been completed and are publicly available for research, social good, and business. Lacuna Fund is guided by a steering committee, a diverse and representative steering committee that provides strategic direction and oversight for our work. And one of the things that they have really emphasized over the past year, now that we're starting to see these data sets come online, is that we want to make sure these data sets get used. Although Lacuna Fund's original mission is to fund the creation, expansion, and maintenance of machine learning data sets, we also want to make sure that the data sets don't just get created, but that they get used for social good. And so there are a number of different ways that Lacuna Fund is trying to support sharing and reuse of the data sets that we have supported. We have developed some guidelines on dataset documentation and hosting, and those are available on the Lacuna Fund website. We also, each time a dataset is completed and published, we share a link to it on the Lacuna Fund website on the datasets page. And there's a link here. Lacuna Fund does not host any of the datasets. The dataset creators decide where the datasets will be hosted, but we just provide links to them so they're easier to find. We also try to share information about the datasets in our newsletter and on social media, and we often support grantees to present their datasets at conferences and events. And with this competition, we're super excited to partner with Zindi to share the Masakhane parts of speech dataset through a competition. And we believe that competitions and hackathons are one really excellent way to raise awareness of the data sets and to increase use of them. And with that, I just want to say thank you. And if you have any questions about Lacuna Fund, you can contact us at this email address. And with that, I'll turn it over to David.
All right. Thank you very much. Yes, let me also share my screen. Okay, great. So originally, this presentation was prepared for ACL conference, which is happening in Canada this week, where a paper got accepted. And I will just give you an idea of how we created a data set, what kind of things you can do with data sets as it relates to the competition. So we call this MaseakhaPOS because it was created by Masekhane, so we just modified it a little bit. part of speech tagging for typologically diverse African languages. This is a large collaboration with many people from my former university, like also Baba Dioni, who is the expert on part of speech that led the annotation effort, and also several people from Masekhane and our coordinator, Peter November. So let's talk about the motivation and what we intend to do initially in this project. So part of speech can be defined as a way of assigning maybe grammatical categories to a word. So you can try to assign, like, if you have a word, the dog chased the cat from the room. So each word is assigned a tag based on their grammatical function in the sentence. And this has a lot of applications. So it's a fundamental step for many applications, including machine translation, parsing, text chunking, speech recognition and synthesis, spell and grammar checking. So it's not that you can deploy a tool called part of speech for commercial purpose, but it's often part of every other tool that are developed, like high-level applications for machine translation to speech recognition. However, for this kind of data set, we do not have a large-scale POS data set for African languages. At the beginning of this project, there was only one sub-Saharan African language that was covered in the standard benchmark data set called UD, and that's Wolof. And we're very lucky that the person that created the Wolof data set was also the one that coordinated the project for MaseakhaPOS, Bambadian. So the languages covered are the following languages. Mostly, many of them are from the Niger-Congo family, because it's also the biggest in Africa. We also have a few representation from Afro-Asiatic like Hausa, Nilo-Shire like Luo, which is also part of the data set, part of the languages that we're trying to do zero-shot transfer to in this competition. We have Setswana, which is another language we want to evaluate on in this competition. So we also have some like English Creole that are quite similar to English, but are very different from other African languages. And this is like the geographical diversity of these languages. You have many of them are located in West Africa, and we also have several in East Africa and some southern part of Africa. And our choice of this data set is based on the availability of volunteers that we know through the Masekhane community. The annotated corpus is based on the news domain. So we collected news articles from the internet, and then we annotated it. And the data set is roughly around 1,500 sentences. We have about 800 training examples, 100 development, and 600 test sets. So we make use of what is called Universal Dependency Guide, and the number of part of speech tags is around 17. So we have like the open class words like adjective, adverb, interjection, noun, proper noun, and verbs. We also have some closed class words and some other categories like punctuation, symbols, and X. X is like, we don't really know how to categorize this. So we have like a non-class where all of that things that cannot be categorized can be pushed to X. The way we have annotated this is that we first manually annotated 100 examples by 3 annotators, and then we train a part of speech tagger based on this 100 annotation. Then we use this to do automatic labeling of the remaining 1,400. And then with this, we combine everything and we try to fix the incorrect predictions. And we have this verification process. We have to do this because part of speech is very tedious task, because you have to label each word to their corresponding tag. And by doing it this way, some part of speech that often occur very frequently, like punctuations, even proper noun, are often annotated automatically with high performance. And those ones are really, that often cause a lot of disagreement can then be fixed by our annotators at the verification stage. Kind of models that we expect also to be used in this competition. For example, we have this conditional random fields, which is an old model, but the performance is pretty decent. And we have the advanced methods like multilingual pre-trained models. We have the massively multilingual ones that have been created for over 100 languages. And we also have the African-centric ones. And I think one of the best is the AfroXLMR large model. So this is like the baseline result. So for some languages, we have for Kiwanda, Shona, Wolof, Yoruba, and Zulu. Most of the time you find that the performance is pretty high. Usually, if you have a training data set for this language, the performance is often over 80%. However, if there's no training example, the performance is often lower. So I'm presenting a cross-lingual transfer result using different approaches. The first approach is called FT-eval, which means you can train on each of these source languages. For example, you can train on Afrikaans and then evaluate on all African languages, and you find that the performance is is lower than the other approaches. So if you just do the naive method in this competition, you train on a combined data set of African languages, and you do evaluation, your performance will be very similar to this blue bar. So we expect that you will go for more advanced methods that requires finding monolingual text in these languages that you're supposed to evaluate on, and use this information to improve the performance of cross-lingual adaptation to the new languages you're supposed to adapt to. So if you want to adapt to Setswana and Luo, we expect that you're going to use one of these methods like LT, SFT, or MADEX. And some of these details can be found in our paper, MaseakhaPOS paper, which is also publicly available on the web. And one thing I would like to highlight is that if there is no training data set, then you can often have a very large performance drop. And that's why most of the performance is in the 60s. You have like 60%. However, if you have training example, the performance is often high, like 85% or more. So we expect that some of the information that has been described in the paper can also be leveraged to get very good performance in this competition. Okay. Thank you.
Are we allowed to ask questions?
Yes, please. You can. I think you can ask questions, right?
Yes, please do ask questions. And then we can ask questions to Jennifer and David on the slides now. And then David, when you do the starter notebook, maybe people can put questions in the chat and we can answer the questions on the starter notebook at the end of the chat.
Also, I mean, I think they can also ask now if it's particular to the question, to this presentation, and also if they have other ones, I can answer.
Yes. So David, I have a question regarding the sample notebook. Should I ask it now or later?
Oh, okay, later.
Okay.
So maybe Amy is just right.
Sure,
so
sure.
that we can do the notebook now. Okay. I guess I can proceed with the sample notebook, right?
Yes, please. Ravindra, if you want, you can put your question in the chat so you don't forget
Sure.
it.
Yeah, will do.
Okay. So let's go to the sample notebook. For the sample notebook, I think you just have to go to we have MaseakhaPOS. And then you have to launch this one. This is the sample notebook. Let me close this one because it's the same. And then you can open in Colab. And this is the example. So the first thing is that you have to install all the modules that you need to run this model. So in this example, we're going to use like pre-trained language models, like I have shared in the in the discussion. So basically, you can pick any of this model from organ phase. So if you go to organ phase, you can search for any of the models. So you can search for birds. So there are different birds. This is multilingual birds that can be used for this competition. Of course, you can also use XLM Roberta. The multilingual birds is by Google, then XLM Roberta is by Facebook. So you could also use any of these. We also have the Africa-centric ones that can be used. So for example, if you go to my profile, you might be able to, okay, maybe we could just search for it directly. You will find some Africa-centric ones, like Afro XML large, can also be used for this competition. So this often provides like better performance based on evaluation. Okay, so this is about the pre-trained language model. So by explaining that, I think I've successfully installed the modules that are required. And after that, you just need to run the others. Like there's nothing to do. You just need to run them. So in this part, what we're doing is just to import the require all the modules we need. We have installed them. We have installed them here, and then we import a lot of we just imported like a lot of methods that we need. And then this is where you okay, sorry. So here you just have to, we define the class where that we can prepare the data set. So we have two informations that are needed. The words, we created a class, one for so the class has two arguments, two major arguments. You have the word and the label, and then you can preprocess your data by creating features using the bedtime approach. And then you can train the model. This is a way to train model. This is fairly standard, so I don't think I need to go into details for this. You have the data loader, and then you have the optimizer, and then you can train the model. And then you can evaluate. So all this you just need to run. And then here, this is where you read the file. So because the data is often in the kernel format, and you can just read the file. Yeah, and then this is a way to start training. And I think the only thing that needs to be modified is, wait, the only thing that needs to be modified is this area, right? So I'm demonstrating this using Yoruba language. So the first thing you're supposed to do is you can clone the repository. And if you clone it, you can find it here. And then you can select the data that you want to train on. So in this example, we are training on one language and evaluating on the same language. So I don't know what, because I'm running the sample code also, and there's no error so far. So I don't really know what happened. And this is it, it's already training. And in the next few minutes, we're going to have the result. So if you can, on your mic, just to explain what is the error, because I didn't modify the code now.
Ravindra, I think I might know what the problem is.
Okay.
So, David, I think the output of your file, output of your code is not a CSV file. So so Ravindra, what you'll need to do is you'll need to create one more cell in the notebook. So you can just do like an add cell. And you just need to take the output of this model and make sure that it is in the format of the sample submission. So it's just one more cell that's needed.
Yeah, sorry, we would provide that for you because it's fairly straightforward.
But can you give me more? What do you mean by I can add one more cell, but what to put in that cell? Like I think I looked at the required format in the competition. It requires some kind of an ID and the POS tag. There are only 2 columns which are needed, right? So how do I get the ID of the tag rather than the actual tag itself, rather than the actual punctuation mark or the
So
whatever right?
So I think,
Yeah.
okay, so you have an ID. So I think you just have to do pre-processing a little bit. So you have to find a way where you're pre-processing to keep track of the ID. And of course, you can modify the code to do that.
Yeah. So David, can we? I'll tell you. Can you look at the actual output? Can you open the YOR folder so that I want to know more details about it? The output of your model actually is running, right? Yeah. Let it
Yeah.
run.
The output of my model is slightly different from the submission formats because what we created is something fairly standard in our community. So once you put it in that format, anybody can pick it up and convert it to another format as they please. Right. So I think if I'm supposed to do that, what I'm going to do is to probably just remove. The problem is I'm not sure I can really, I'm not able to share this file, but I can go through it quickly. So in the sample format, you have ID, word, language, and POS, right?
Yeah.
So what you can do, because anyways, you're going to train a multilingual model. Okay, I see. So Amy, I think it is the way you pre-process the data set. So for example, there's no space. And I think this is why they have some issues.
What we can do, Ravindra, is hopefully by Monday evening, we can we'll add it in the discussion forum, like a cell on what you need to add just to do the pre and post processing.
Yeah, I think if there's a way to post-process easily, but to be honest, I don't think Zindi needs to provide this because you can just write a code to do this yourself.
Yeah, absolutely, David. I think I can write the code myself, but what I need to know is I don't want to spend the time in correcting the format. If you can give me the correct, actually it is one of the things that I'm struggling with. It is not a CSV file at all. Even if you look at the sample submission, I don't see any comma that separates the data. So is it a CSV or a comma separator or a tab separator? If you can give me the ideal example that works, that's good enough. I don't need the code.
So for example, I'm still sharing my screen, right? You can see.
Yes.
So this is the test predictions.
Correct. And this is not in the right format.
I mean, this is in the right format. But
no, if I try to submit this, right, David?
Of course,
I get an error.
Yeah, you cannot submit this because it's not in the same format.
So what do I need to change here?
So that means you have to first convert what you are provided with into this format. So you need to write a code that just separates it. So for example, you can separate by period, by full stop. You can just add a space and convert the comma in the CSV into space in this format. Then if you write a small script to convert that to this one, then you can run your prediction using this code. And then you cannot take it back to the other formats. Basically, you just remove the periods. You just remove the space after the periods, and then you're already back to the format of Zindi.
Okay, well, where do you get the IDs, right? If you look at in the GitHub, right? We don't have to write the actual text. We have to write the IDs of the text. Where do I get the IDs?
So what I'm saying is that if you want to do the prediction, you can ignore the IDs completely.
Okay.
Or you can create a dictionary to map each word into the right ID. I think because, for example, when you want to run the prediction, if you use this maximum sequence net of 200, I think nothing is going to be truncated. So the only difference is that this space that you have here, like in this output, you just remove it. to fit what you have in the Zindi competition.
And
So-
do I need to add a comma after the each text, because this is not a comma separated file, right? This is not a CSV file.
No, this is not a CSV. This is just like it's a space that is separating them.
Correct.
You just have a space separating this, right? So you just need to convert that format to this format, run a prediction, and convert it back.
Yeah, and if you take a look at line 43, David,
Yeah.
there is a comma itself. So how do we differentiate between this comma and the comma separation, right?
But CSV can easily undo this. If you load this in pandas, it's going to just put this in quotes, and then you have another comma. So I don't see this as an issue.
Okay.
And also in the Zindi, the file they have provided, you can also have comma. There's also comma there. There's full stop, which was not deleted at all.
Got it. Yeah, we'll do that. Yeah, entirely.
Yeah. So, sorry for that you have to do that, but I think the way we have prepared this code is something that, regardless of which computation is used for, it's fairly standard. So this is a kernel format in our community. So we often try to retain this.
Thank you, David.
Yeah,
This is good.
sure. So do we have other questions?
Yeah, if you've got any more questions on the code, how to make a submission, or just in general, what is parts of speech, this is a great opportunity to ask. We will record this. This is being recorded and will be posted on the competition page, so you can come back and view it. And if you can't think of a question now, we will answer them on the discussion board of the competition. But there's a question from Julius.
Yeah, I
David.
think there's a submission sample in Zindi, correct or incorrect? If it is, we can just follow that. I mean, the submission format in Zindi is correct. I think some people have already made submission. Like, for example, in the letterboard, we already have like a couple of submissions, right? So, so I think it's just to add the script that will do the conversion. If Zindi is happy to provide that, that's fine, but I think otherwise you have to provide it yourself. Yeah. So for Julius, cannot import name. Okay. Did you run the same code, or I don't know, because I couldn't find it.
Yes. I'm running the same code as you're doing. And
Yeah.
in the last of the cells, down towards the bottom. Actually, the last.
But I think, okay, so one thing you have to note is that the code ends here. This is where it ends.
Okay.
Because you already get your results.
Yeah, definitely. Yeah.
I mean, this is, sorry. So if this is what you need, right? This is a sample of how to run a model. So, and we want to do training, evaluation, and prediction. Once you run this one, that's it. You just need to modify this part.
Okay.
Yeah.
Noted. Thank you.
So this is another example, which you don't need to. This is just like if you want to use another sample model. Yeah.
Can you scroll? That's the last part of your.
Yeah. This last part is incorrect because why it's wrong is that you have a BERT and then you have XLM Roberta. So these are like two different architectures. So you should pick the right one. So for example, if you want to use BERT, then you have to use multilingual. Let's see. So you have to use this one. This one will give you the right answer. Yeah, if you do this, I think this should work. Also, you have to change this because it says you have to change. What is the data part? You have to check the data part. I think is Swahili, and then maybe this will work now. All right.
Thank you.
I think depending on how you define it, you're training, you're also fine-tuning. Depending on how you define it, because to train a model using pre-trained language model means to actually fine-tune the encoder. Is that what you mean? So one thing I want you to understand is that this is just a basic way of doing things. There are also different things that can be done. So if you just run this model, you are not going to win this competition, definitely. Because this is just running a model for one language. Ideally, what we expect is that you're supposed to combine other languages together. You combine the training data set and then fine tune it. Also, you want to consider languages that are similar to that language you're targeting to give you a good result. And that's a challenge. So we expect you to think a little bit out of the box to be able to have a very good result. Yeah.
Hey, David, we've got a question from Kenya. We are supposed to, I believe from the data sets, we are supposed to train with the train.txt file and submit the test.txt. Why are we provided with the dev text?
Okay. The dev set is just for you to tune the hyperparameters of the model.
David, correct me if I'm wrong, but I think it goes back to that slide where you said that there's a 20% decrease in score.
But this is okay, this one?
Yes. Yeah.
Okay.
Maybe it's not. So my understanding is that you can reuse train and dev independently, or you can merge them together. Dev is just there as extra if needed.
Yeah, dev is just there if you need it. For example, for tuning hyperparameters and then evaluating on the test set. Yeah. For Abraham, no, we're not doing any pre-training. I don't know where you see pre-training. Because we're just like fine-tuning an encoder on a model, like Pratt model on a downstream task. What do you mean by pre-training? If you can. Yeah, and I don't think you need a lot of compute power because you can run this using Google Colab, and you can see it's pretty fast. In 10 minutes, you're done. Like, yeah, I mean, it's very fast to train this model. In like 5 to 10 minutes, you're done training. So it's super convenient. So of course, this is just one language. If you combine all the languages, maybe it's going to take like 30 minutes, 1 hour to train. But if your computer is on, I think you'll be able to train.
Please feel free to unmute yourself if you want to ask a question and you can engage with David.
There's no limit. Yeah. So search for scientific papers, read more papers to find ways to like get good performance. So I think the tricky thing with this competition is that we did not provide the training examples for Setswana and Luo. So like I shared here, if you provide a training example, you often have a very good performance of like over 85%. But if you don't provide any training example, you have something very low. And this is where you can actually innovate, right? To see what language are you supposed to benefit from. In our paper, we show that if you train on Wolof, for example, it can do very well on other African languages because it's also an African language. So we have also provided data for several African languages here. So you can try to to decide which of the languages should you train on that will give you good performance for Luo and Setswana. Yeah, Abraham.
Yeah, so since the model is going to be, our results are going to be evaluated in a multilingual manner, is training on the entire data set provided for the competition not supposed to be like the normal way to go for it?
Yeah, of course, that's the normal way to go for it. But that doesn't mean, of course, if you do that, your performance is it will be very similar to this blue bar. You see? So I'm saying that this is not the best you can do because you're just fine-tuning on the entire data set. And this will give you a decent performance, but I don't think you win a competition that way. You might need some more advanced methods.
So what's in the orange bar?
It's called LTSFT. All these details have been explained in our paper, which I can. Yeah, so all these details have been explained. We describe some of these models. We also describe how to do cross-lingual transfer. So we have an entire section on baseline experiments, and then we have another section on cross-lingual transfer. And for example, we ask questions. How do you get a very good cross-lingual transfer? So the first thing is that you have to choose what is the good source languages to transfer from. Because you're going from other languages to languages not same. So you need to look at some criteria. So the criteria we use is maybe availability of POS training data. Here we have provided 18 data sets. So this is, you can use any of the 18 to see which is the best language to choose from. You can also use what is called geographical proximity. So if you want to go to Setswana, you can check the map. I think in the map I have provided that you can see that Kiswahili is closer to Setswana compared more than Yoruba. So if you're trying to do the adaptation from Yoruba, you might get worse results than if you're trying to do it from Kiswahili or Shishona, for example. So these are some of the details you can see. Also, language family similarity. If two languages are similar, then maybe you can get very good performance. And also we have this method called parameter efficient cross-lingual. So this parameter efficient cross-lingual approach is what is called LTSFT and MADEX. And you can read more and just follow some of our approach. I'm not saying this will guarantee that you're going to win the competition, but this is one way to boost your performance.
So just to confirm though, David, we can use multiple languages. We're allowed to use multiple languages to train on, correct? We don't have to just choose one.
Yes, you can use multiple languages. And actually we show that if you do multi-source fine-tuning, you can improve the performance.
Perfect. Okay, thank you.
Yeah. So using multiple languages. But maybe just combining all of them at once may not be the right approach. You have to carefully choose what are the languages I need to combine. And for example, I don't even know myself. So you have to do some experiments to see how do I decide? And some of the guiding principles would be, are they like geographical proximity, language family similarity, what is available, and then you can think of other some heuristics to combine this language. Yeah.
Something David told me, and it's visible in that map, is that Luo is from that Hausa region, and Setswana is from the bottom region. So yeah, maybe joining all the languages together might not be the best idea.
Yeah, like if you join all the West African languages, I think you are pushing yourself further away from the solution, for example.
You do have 300 submissions to make over the course of the competition, so you can do 300 experiments. Not many people get to 300, but I wish you all the best. On Zindi, we say that there's only learning, no losing. So I know David's pushing you to win. I'm pushing you to learn and to just experiment.
Yeah, sure. So that's really good. I mean, one good thing is this is actually a very active area of research. So if you have a very good solution, I think you can write a paper like almost immediately on this. And you might even be surprised you can get accepted to a very good conference. Because the solution is not obvious, right? How do you choose a language? How do you combine these languages? It's not very clear. So we did some initial experiments, but I think if you start with that, yeah, there's a lot of things to learn, just like Amy said. There's many things to learn. Yeah.
I'm going to give 30 seconds for someone to raise their hand or to type in the chat. And if there's no one, we can wrap up the webinar.
So just one question. The only way to ask questions going forward is through discussion forums on Zindi, right? Is there any other way? Okay. Right.
Someone on the Zindi team does check the discussion board weekly. You can also reach out to the top people on the leaderboard, but we do check it weekly. So just give us 7 days.
Thank you.
Kenya?
Yeah, I want to say thank you very much, David and Zindi as a whole for this opportunity. I feel that we actually don't have limits, so we can use any pre-processing method. We can use GPUs to any extent. So I'm really glad. And not like a question, I just want to appreciate you guys. Thank you very much.
Yeah.
Amazing. Thank you, Kenya. Okay, David, thank you so much for your time tonight, walking us through the notebook and your work with all your colleagues in creating this data set. You showed us why it's really important. And I hope some of our Zindians can crack the egg and figure out the right data sets, maybe even get a paper.
That would be amazing. Yeah.
And Jennifer, thank you so much for the opportunity to have this experience. And thank you for the work you do, you and your team and Meridian and Lacuna, on pushing for data sets to be created.
Yeah. Thank you.
Thank you.
Good night, everyone. Thank you so much.
Good night. Thank you. Thank you, Jennifer.
Thank you, everyone.